Hello everyone, welcome back to my channel. In this video, we are going to master data manipulation and broadcasting in PyTorch. These are critical skills that you will need every day when building machine learning or deep learning models. So let's dive right in. So let's start with the basics. First, we will see how we can do indexing and slicing in tensors. These operations allow us to pick specific part of our data easily. So to import the PyTorch library, you can simply type here import torch. Next, we are going to create the tensor. So I'm going to create a variable tensor is equal to, and to create the tensor you can simply type here torch.tensor, and we are going to create a two-dimensional tensor. So you have to put big brackets here inside this small bracket, and next you have to create one more set of big brackets here, and you have to put comma here and one more set of big brackets. So I'm going to create the matrix with the dimension of 2 cross 3. It means I'm going to create a matrix with 2 rows and 3 columns. So first we are going to fill our first row with the 3 entries. So you can simply type here 1 2 3, and for the second row similarly you can type here 5 5 6. So our matrix is created with the size of 2 cross 3, and to visualize it you can simply type here print tensor, and to see the results you have to save your file and open your terminal. So I'm using Python 3.12, and to run the file you can pass your file here and press enter. As you can see that our matrix is created successfully with the dimensions 2 cross 3. In the first row we have 1 2 3, and in the second row we have 4 5 6. Next we are going to just pick the specific element from this whole matrix, and I'm going to pick this element 2 from this whole matrix, and this 2 is in first row and second column. So how we can pick this specific element? So you have to again copy here and paste it here. So to pick the specific element from this tensor you have to put big brackets here, and our element is in first row and second column. First we have to put the row number here. So our row is first row, so you have to put 0. So it start from 0. So 0 means first row, 1 means second row. Next we have to choose the column, so you have to put comma here, and our element is in column 2, so you have to put 1 here for the second column, and save your file and run it again to see the results. As you can see here, this time we have just picked the number 2 from this whole matrix. Next, if you want to pick the whole row from this whole matrix, so how you can pick the specific row? So for this I'm going to copy it again and paste it here. So how you can pick the whole row? So you have to again pass the row number. For example, I'm going to pick this first row, and we need all the elements from the first row. 1 2 3. So you have to remove 1 from here, and you have to put colon here. Colon means range, so it means we are going to pick all the elements from this specific row. Save it file and run it again to see the results. So as you can see here, we have just picked the first row from this matrix 1 2 3. Next, if you want to pick the specific column from the whole matrix, you can simply copy this one and paste it here. And now you have to replace 0 with the colon sign, because we need all the elements from the rows but from a specific column. So I'm going to choose the second column, so I have to replace 1 here. 1 means second column. Now save your file and run it to see the results. As you can see here, now we have tensor with the elements 2 and 5. 2 and 5 are the elements from all the rows but from the second column, as you can see here also. And next, if you don't want all the elements, for example from the first row, you only want the elements 1 and 2. So how you can do it? So you can paste it here. So again you have to select the row. So our elements, for example 1 and 2 are placed in the first row, so you have to put 0 here. Next, we choose only the columns first and second column from the first row. We don't need the third column. So now you can put the range here, and you have to put the limits here. So how you can put it? Start from first column and end at third column. So you can simply type here 2 for the third column, save it, and again run your file. Now this time you can see that we have only picked 1 and 2 from the first row. So this is how you can do indexing and slicing in tensors. So you can also do it for Boolean operations. So how you can do it? For example, again copy it and paste it here. This time you need elements that are greater than, for example, 3 or 2. So you can again put your tensor here inside this big brackets, and this time you have to put the greater than sign here, for example, and we need all elements that are greater than 2, and put 2 here and save your file and run it again to see the results. As you can see here, we have only choose the elements that are greater than 2 in this matrix, 3, 4, 5, 6 here. So this is all about indexing and slicing in tensors. Next, we will see how we can do reshape tensors. This is crucial when preparing data for neural networks or aligning dimensions to perform arithmetic operations on tensors. For example, in our case, we have created the tensor with the dimension of 2 cross 3, 2 rows and 3 columns. And now for our next step, we want this tensor to be 3 cross 2 instead of 2 cross 3. So how we can change its structure or reshape this tensor? For this, you can create a new variable, for example, tensor1 and equal to, and to change its structure, you can simply call this tensor here and put the dot here, and you can use the reshape function, and here you can specify the rows and columns, how much rows and columns you want for this type of data. So the possibility to change or restructure this tensor is from 2 cross 3 to 3 cross 2. So how we can do this? You can simply put the number of rows first here, 3, and we need 2 columns. Save it, and now we are going to visualize our tensor. For this, you can simply type here print tensor1, save your file and run it to see the results. And here you can see that our initial tensor has 2 rows and 3 columns, and it has increased 1, 2, 3, 4, 5, 6. Now we have restructured this tensor from 2 cross 3 to 3 cross 2. Now we have 3 rows and 2 columns, and our elements are now here like this, 1, 2, 3, 4, 5, 6. You can also add or remove dimensions using squeeze and unsqueeze methods in PyTorch. These are really useful when working with the batch dimensions. Remember that you can only add an extra dimension that has a size of 1, and similarly you can remove the dimension that has a size of 1. So what does it mean? We will see. First we will see the size of our tensor1. So to see the size, you can simply type here print tensor1 dot size, and you have to put brackets here and save it and run it to see the size of the tensor1. And you can see here the size of our tensor1 is 3 cross 2, and you can only add an extra dimension that has a size of 1. So first we will remove an extra dimension, and remember that you cannot remove the dimension from the current tensor1 because it does not has a size of 1. So first we will add an extra dimension to this matrix. Right now our tensor has 2 dimensions. Now we are going to make it 3-dimensional tensor. For this, you can simply go down and type here tensor1 is equal to tensor1. To add an extra dimension, put dot and use unsqueeze, and you can either add the dimension in the start or in the end or in between. So I'm going to add the dimension in the start, so I have to put 0 here, index. I'm going to save it, and now I'm going to print and see the shape of my tensor1 or size. You can simply type here tensor1 dot size, and now we will run our program and see the changes. As you can see here, my old tensor1 has size 3 cross 2, and it is a 2D sensor. Now it becomes a 3-dimensional sensor, and it has added an extra dimension in the beginning, and it has size of 1. It means it has no elements or 1 element. Next, if you want to put this extra dimension in between, for example 3 cross 1 cross 2, so how you can do it? You can change the index here. For example, if you put in between, just place 1 here and save and run it again to see the changes. Now you can see that our old torch one is of dimensions 3 cross 2. Now it becomes 3 cross 1 cross 2. So it has added an extra dimension that has a size 1. So similarly, you can use the squeeze method to remove the extra dimension. And now we are going to remove the extra dimension that we have created in tensor1. You can copy it again and paste it again down here, and you can remove the un from the squeeze. So to remove the dimension, you can simply use the squeeze, and we are going to remove the dimension again from the first index, which has a size of 1. Now if I run my program again and see the changes, as you can see here, our tensor1 in the start has the dimension 3 cross 2, and later we have added an extra dimension at the index 1, so it becomes 3 cross 1 cross 2, and again we have used the squeeze method to remove this extra dimension. So this is how you can add an extra dimension or remove the extra dimension from your tensors. Next, we will see how we can combine two tensors or matrices together. In our case, tensor 1 has the dimension of 2 cross 3 and our tensor 1 has the dimension of 3 cross 2. So according to the matrix rules, we are unable to combine these two matrices in their current form. So we have to reshape our tensor 1 again from 3 cross 2 to 2 cross 3. And we can use the reshape function, or we can also use the transpose to convert it from 3 cross 2 to 2 cross 3. So this time we are going to use the transpose. So you can simply type here tensor 1 is equal to tensor 1. We have to take the transpose of this tensor. Just type capital T here, and next after the transpose we can combine our tensor 1 and tensor. So how we can combine it? So I'm going to create a new variable with the name of combined matrix is equal to, and I'm going to use the torch.concat to combine our two tensors, and the first argument is the tensors, and you have to put bracket here, and our tensors are tensor and tensor 1. And next we have to give one more argument, dimension. So dimension means if you want to combine these two matrices along rows or along columns. So if you want to combine it along rows, you have to pass here 0. If you want to combine these two matrices along columns, you have to pass here 1. First we will combine along rows and see the result. We can print here our combined matrix. You can save it, and we can also print its size. And now we will run our file and see the changes. As you can see here, the concatenation is successful, but you have to notice one thing here. With the concat function, the dimension of our matrix doesn't change. It's still a 2D tensor. So it has add this tensor along the rows. So you can see here 1 2 3 4 5 6, and this is our tensor 1 again. For example, 1 3 5 2 4 6. And now our combined matrix has the size of 4 cross 3. It means now we have 4 rows and 3 columns, and it is a two-dimensional matrix or a tensor. And now we will see if we want to combine these two matrices along columns, what will change? Just type here 1 and run your file again. Now you can see that 1 2 3 4 5 6, and this is our tensor 1 1 3 5 2 4 6. So now the size of our tensor is changed from 4 cross 3 to 2 cross 6. So this is how you can combine these two matrices. But if you want to combine two matrices and you also want to increase the dimension and you want to combine the new matrix with an extra dimension, so how you can do it? So we are going to copy it again and paste it here. This time instead of concat, we are going to use the function called stack. And for example, now I want to add this tensor 1 as an extra dimension. So it will combine this tensor 1 with the tensor. 0 means in the start, not in the between. So if I run my file again, you will see the changes in the shape. Now you can see that it changes from 2D matrix to 3D matrix. Now it become a three-dimensional tensor if I use the stack. And you can see that this is my first 2D matrix 1 2 3 4 5 6, and now it is again create another 2D matrix of tensor 1, which is 1 3 5 2 4 6, and it is becomes a three-dimensional matrix. And here if you see the size, you can see here our old matrix has the dimension, for example 2 rows and 3 columns, and now we have add this new tensor 1 along our tensor as an extra dimension here, and it has size of 2. If you want to add in between, so you can pause 1 here. Now run your file again. So it means now it will create again the three-dimensional matrix, but this time the extra dimension comes here in between. So if you want to put this extra dimension in the end, so how you can do it? You can pass the dimension to here and run your file again. Now you will see the changes here in the tensor also, and you can see the size here. Our original tensor has the size 2 cross 3, and we have combined another tensor which is tensor 1 along tensor as an extra dimension, and you can see here 2 cross 3 and this 2 here. So this is how you can concatenate or combine your matrices or tensors. So in the end we will see what is broadcasting. Broadcasting is a powerful feature that allows PyTorch to perform arithmetic operations on tensors of different sizes by automatically aligning them. we will see how he can do it. We are going to create another tensor. We will name it A, and to create a tensor, again torch.tensor, and here we are going to create a one-dimensional tensor. So I'm going to pass here 1, 2, 3. In broadcasting, it's must that your one tensor should be one-dimensional and your another tensor should be of any dimension. And next we are going to print the tensor A, and we are also going to print its dimension. For this you can type here a.shape, and we are going to create another tensor and we will name it B, and we will make it a two-dimensional matrix, and we can type here 4, 5, 6, and we will close it here, and we have to again change here A from B, A from B. Save your file, and next we are going to calculate the sum. We can perform any arithmetic operation on it, so I'm going to just perform the sum A plus B, and next I'm going to print the result and also the shape of the result, so result.shape, and save your file and run it to see the results. And here you can see that this is our tensor A, and it has elements 1 to 3, and its size is either 1 cross 3 or 3 cross 1, but right now its size is just 3, so it is a list or 1D array. And our second tensor is two-dimensional, and it has 2 rows and 3 columns. Now we want to add these 3 elements to this. So how it will automatically align them? So it will create the shape of this one-dimensional matrix according to the matrix addition rule, and then it will add it by element wise. And here you can see the results. 1 plus 1 is equal to 2, 2 plus 2, 4, and 3 plus 3 is 6 in the result. So this is how the broadcasting works. It will automatically align the tensors to perform the arithmetic operation. So this is it for today. I hope you have liked this tutorial, and if you want to learn more about PyTorch, you can subscribe my channel and also press the bell icon to get the updates of the new uploads. See you next time. Bye bye.